Thank you, Stephen. Hello, everyone. My name is Sharon Azulay. I'm the CEO of Plexistor, and I'll give you a brief overview of the company. Quickly, just a quick background about the company. We've established Plexistor in 2013. We've been, it's a team that came from Panasas, Primary Data, EMC, a lot of storage experience, enterprise-grade storage experience. We've just released our core technology, which we'll describe in details in this presentation, beginning of this year. So it's out there, you can download it, you can use it, it's pretty much free. We are based in Mountain View. Development is done in Israel. I'm going to stay there. We've got approximately 18 employees and a bunch of patents covering the technology, which we'll see later in the presentation. So I'll start with the business challenge. What we are actually trying to solve, and one of the things we've realized is that talking to organizations, the biggest issue dealing with big data is really how quickly they can come to a decision based on the data they are collecting, and what's the quality of the outcome. And it all translates eventually to the amount of data and the variety of data. Of course, velocity or speed is just increasing. The more customers you have, the more IoT devices you've got, the more you need to process it more quickly in order to come to accurate and fast answers. And it's actually creating a very interesting challenge to the IT. It needs to deal with huge amount of data, not just from the networking perspective, but also from storage perspective, processing, how to store it eventually, and going forward, how to simplify or maintain the same level of simplicity we used to have at the infrastructure level, and at the same time maintaining the same level of performance. What we are seeing usually, we're starting great, everything is excellent in the first month, and then slowly it's degrading and drifting into a very low performance, and then we get into a crisis, we need to fix it. So those are the challenges we are seeing. Just to set the stage, especially in the big data, the amount of investment is actually increasing. We've seen companies investing almost 50% in infrastructure, buying more servers, buying more storage in an attempt to address the increase in data and the velocity and the variety of data. And it's all, again, based on IDG report in order to maintain the accuracy and the quality and the speed of analysis. This new kind of data, this new amount of data, this new speed of data created a new breed of applications. Applications that pretty much gave up on storage altogether, relying only on memory technology. Why? Because memory is the fastest we can get. It's the closest to the CPU. It gives us a different kind of properties from storage. We don't need to load it from slow device in order for the CPU to do something with it. So we're going to see applications like Cassandra and MongoDB and Redis that are not using storage at all, just pure memory. They are experiencing some issues. What do we do when memory is exhausted? What do we do when memory is really expensive? What's the trade-offs? What can we do in order to make the system more economical and at the end of the day deal with more data? So we can see different scenarios. Cassandra is telling you, listen, you need to buy more machines. Add more machines, we'll shard the data, we'll do some sophisticated stuff, but at the end of the day, you're going to get a huge, enormous data center. Some, for example, like Mongo saying, you're going to spill the data. Once you're exceeding the memory size, data is going to spill over to storage, to slow storage. So this breakpoint or this tipping point, when you get into that, you're seeing an enormous degradation in performance because there is nothing we can do about it. Storage is slow in compared to memory by a factor of 1,000 at least.
And what do you do when the power to the data center goes off and the generator doesn't start? Because
exactly.
Those things are 50-50.
Absolutely. And we didn't even get to the fact that the entire concept of DRAM is volatility. We are counting actually on the volatility of memory, and relying on that, on memory as a storage device, means that we need to find different ways to maintain persistency. And it created actually a very interesting situation where customers are saying, listen, for the sake of performance, for the sake of being able to process the data and get answers fast, let's give up on the data. If I'm experiencing power failure, I'm going to lose the data, probably half an hour, maybe a day. And it's not an easy trade-off. What it does is actually limiting the use cases of those applications to cases where you are willing to count on the statistics rather than on the data itself. So what we're seeing today is that, again, big data cases are very narrowed to locations, to applications or situations where we are willing to, worst case scenario, lose some data. Those applications actually introduced new requirements from memory, from storage, from the entire system, actually. They're expecting low latency. They're expecting memory latency, nothing less than that. They are generating an enormous throughput on the memory channel, bless you. And they are created, again, a new kind of storage requirements, durable and ephemeral at the same time. So some applications are going to say, listen, I'm not willing to give up on the last transaction. Some are going to say, like Cassandra, I don't care. You can lose the machine completely. I've created a replication set over the network. The other machine will take responsibility once this machine is failing. So we are getting, from storage perspective, for us as people that build enterprise-grade storage, it sounds, it's different. We don't understand completely how to address those requirements. It's not an out-of-the-box feature set to provide. What Plexistor is trying to do is to provide a new approach to storage. We are trying to make it really, really efficient, really simple, and really elastic from your perspective, to get to a point where, you know what, you don't care anymore. You don't want to know if the application is consuming memory, if it's consuming storage, if it needs ultra-low latency, if it's generating huge amounts of throughput, if it needs durable or ephemeral. We need to get to a point where I'm deploying it and I'm working with it, and that's it. Okay? And that's exactly what we're trying to do. We are trying to understand exactly what are the application requirements and build a solution that can address the application requirements of big data and at the same time our legacy applications. And the bottom line, deliver durable and ephemeral storage at near memory speed. This is the main theme, for storage, for our solution. So what Plexistor is eventually doing, first of all, just to put things in perspective, what Plexistor is doing is a pure software solution. We are not an hardware vendor. We don't ship boxes. We are shipping software licenses. And what we've created is a software layer that runs on top of your infrastructure and enable you to create a symmetric, very elastic, very simple to use infrastructure where you can run your applications like Redis and Orton and MySQL, regardless of their specific requirements. So Redis is going to ask for a huge amount of memory, and MongoDB is going to require very ultra-low latency storage in order to deal with the spillover from memory to storage. The architecture is scalable to hundreds of nodes, and we'll see later how we can actually do that. It's relying on containers in order to provide simplicity in management, but we are not relying on containers to provide a solution. The solution itself is a bare metal solution. It doesn't rely on anything other than the operating system itself. You can run containers on top, you can run KVM on top, and you can run Yarn on top if you are a big data guy that wants to just provide a big data infrastructure. This infrastructure enables you to, again, provide an answer or answer the demand of any kind of application in the enterprise.
So is this just for big data, or is it for smaller applications as well?
I'm sorry, can you say that again?
Is the use case just for big data, or is it for more traditional applications as well?
So the use cases that we are trying to cover, again, we are focusing on big data because those kind of applications are the ones that are the most intense, I/O intense and memory hungry applications. Okay, but we can at the same time provide a solution for MySQL. Okay, which is not a memory-oriented application, but it's I/O-intensive application, and we've been able to show up to 3x improvement in MySQL performance, just out of the box, no changes, nothing.
So if it's bare metal, though, can I put anything on top of it? Can I put my VMware environment on top of this?
So the solution is relying on Linux operating system. You can put KVM on top, and you can put OpenStack on top. But VMware is its own kernel. It's not compatible with anything, and it's not an open system. So for us to provide a VMware solution, the only way is to run Plexistor inside the virtual machine itself and gain the benefits of Plexistor through the virtual machine. Not as a VSA, but the Plexistor is going to provide the services to the VM itself. Okay?
So you're running the Plexistor solution on the same systems that are running these applications.
Exactly.
This is not a storage target
No, it's
in the
not.
traditional sense?
So the solution is a converging solution. It tries to provide the same level of simplicity and elasticity that you're gaining from other converged solutions. The difference is the target market that we are trying to approach. We are approaching applications that are I/O intensive, CPU intensive, memory intensive, not necessarily the common use cases that we are seeing today with hyperconverged. Okay.
So could I quickly summarize it as a converged infrastructure software product that is designed especially for big data? But
Absolutely.
Not that it only does that, but that's
absolutely
that's
the first. That's
your
the
one
first
line.
market.
Okay.
Absolutely.
So, from what you are saying, it looks like a VSA, virtual storage appliance, which is not, right?
It's not.
Okay.
So other hyperconverged took a different approach, where one of the virtual machines within the hypervisor is managing the storage and exposing it back to the other virtual machines, either as an iSCSI target or as an NFS mount point. The drawback of that approach, and again, it's okay for certain applications that are not latency sensitive can live with that kind of configuration. But applications that are very much latency sensitive, what it means is that the data is actually flowing between the virtual machine, going back to the hypervisor, going back to the target machine, to the target virtual machine, and this process, this flow actually adds lots of latency. And this is exactly what we are trying to avoid. And this is, by the way, why you're not going to see too many customers actually running big data applications on top of hyperconverged because of that path.